Hi, welcome to Dr. Raz, the Baking Chemist. So today is all about reactions of ions in aqueous solutions, ligand exchanges, ligand substitutions, blah blah blah. This is a year 2 or year 13 topic. This is one of the questions with all the various letters of the alphabet, which the examiners love, as I told you before. Let's do this. Okay, so the question is, the following tests were carried out to identify an unknown agent, green salt. Okay, so there's an immediate clue. Why did they mention the phrase green? You know, there's a reason, isn't it? An aqueous solution of Y gave a cream precipitate. So aqueous solution of Y gave a cream precipitate. Lots of colors, as you'd expect in this kind of a topic. This is obviously a year 2 topic. And it's all to do with transition metals and aqueous ions. So cream precipitate of a compound A. So this gives you that. When react with silver nitrate, immediately I'm thinking, okay, what do I know about silver nitrate? Where have we used silver nitrate? Okay, so that's a test for halides, if you remember. So okay, so it could be that they're testing for a halide. Compound A gave a colorless solution. So once they formed the compound A gave a colorless solution when reacted with concentrated ammonia solution. So again, where have we ever used concentrated ammonia solution in one of our tests? Another aqueous solution. So this is now another aqueous solution of Y. So not the same one, but a separate solution. So it's the same Y solution, but it's just that they're taking a fresh solution for the next test. Gave a green precipitate of B when react with sodium carbonate. Okay, the green precipitate B was then filtered, dried, and then reacted with sulfuric acid to give a pale green solution containing compound C and a gas D. Identified by name or formula the compounds A, B, C, D, and Y. All right. Okay, so this is one of those questions where if you've not sat down and actually memorized your inorganic chapter, transition metals and reactions of aqueous ions, and these colors, etc., you're going to struggle. I always tell my students they need to sort of sit down and actually memorize the complex ions and the colors and their reactions with carbonates, with sodium hydroxide, with ammonia, etc. There is always a summary. So whether you're doing AQA or whether you're doing Edexcel, find a summary sheet. I know AQA have a summary sheet on their website, on their AQA exam board website. Print it out, memorize it, sit down, memorize. I know also that Edexcel, I'm not sure whether they have this summary sheet on their website, but there is a summary sheet which I know it exists. I've seen it. I've just seen it just before this video. So it does exist. Print it out, memorize it. There's no shortcut about this, okay? If you don't know, then this question becomes a little bit more difficult for you. You might still be able to do it, but it becomes a little bit more difficult for you, okay? So let's do this, right? So I'm going to start with, so obviously this is a green salt Y, so right, so let's start with Y, okay? And then Y becomes when they react it with silver nitrate. Now I know silver nitrate is a halide test, okay? So I know they're testing with halides. All right, but anyway, I'm not going to jump the gun just yet. Silver nitrate, and then it gives you a cream precipitate of compound A. All right, so I know also that the cream precipitate is usually bromide, okay? But if you remember, chloride is white, precipitate, bromide is cream, and then iodide is yellow, yeah? So chloride, in fact, I'm not going to write it. So bromide, so that is likely to be a bromide ion. Okay, cream precipitate. Okay, oh, I should have put PPT, but never mind. Okay, so that's the bromide. And then what do? Compound A gave a colorless solution when reacted with compound A gave colorless solution when reacted with. Okay, so we also know that sometimes it's not very easy to tell apart the various colors between the chloride, bromide, and the iodide, white, cream, and yellow. So it's not very easy. So what they do is we can put dilute ammonia, okay, and dilute ammonia will dissolve the white precipitate if it was a chloride, and if it does dissolve it, then you know it's a chloride. The bromide will not dissolve in dilute ammonia solution. So what then you do, so if you've added dilute solution of ammonia and nothing happens, you then add concentrated ammonia, okay? And then if it dissolves, you know that that precipitate was a bromide, okay? It was due to bromide, all right? And what they're saying is they're adding concentrated ammonia, and then it forms a colorless solution. So with concentrated ammonia, it dissolves. So you know that this is, so colorless solution, so you know that this is definitely a bromide ion. Remember, we're trying to identify why, yeah, a compound has a sort of a salt, yeah, has a metal and a non-metal. So obviously they're trying to do different tests to identify the metal part and the non-metal part. We've just identified the non-metal part of this salt, yeah, of this salt. Green, if I'd done my sort of memorizing work, I would have said, all right, in transition metals, etc., what do I know that exists as green? I immediately know, okay, usually iron compounds are green, and they're iron 2+ compounds, not iron 3+. Can you see? I know that because I memorized it. But if you've not memorized it, let's continue. So I found out bromide. Okay, so that's that. Now the next part. So I've done that part. Next part. Another aqueous solution, green precipitate B when react with. So we've taken a separate Y, and we've added to it sodium carbonate, and that gives us something called B. Right, so this is a green, say it's a precipitate. Okay, now this is a green precipitate. Now what you should have known is that green precipitate at this point, if you don't know what kind of transition metal complex, yeah, is green, in terms of green precipitate, so it's in those summary sheets, yeah. If you're not, then you're going to struggle to find what that is, okay. But anyway, so if you have done it, then you'll know that then this green precipitate is actually probably, because remember, what kind of ions, transition metal ions, react with carbonate to give a green precipitate? Well, you should know that it is actually Fe, so iron carbonate, yeah. So it's probably iron carbonate, and it's Fe2 oxidation state, okay, not Fe3. So this must be FeCO3. Now, what do they then do with it? The green precipitate B was filtered and dried, and then so there was a solid green precipitate, and there was nothing else reacting. Is reacting with sulfuric acid to give a pale green solution containing compound C and a colorless gas. So what they do is they take that and they react it with H2SO4. This precipitate, so obviously if we know at this point that B is FeCO3, and even if you didn't, you would have known that B, if it reacts with sulfuric acid and it gives you a gas, well, what kind of a compound usually react with acid to give you a gas? Yeah, they're metals, metals react with acids to give you gases as well, hydrogen. But remember, these aren't just metals, this is a salt, right? So the salt is reacting with the acid to give you a gas. Now that gas is most likely to be carbon dioxide, so I immediately know that it's likely to be carbon dioxide. Okay, but anyway, let's see. So what's probably happening is, hold on, to give pale solution compounds C and D. So they're giving you C and D, and the C is obviously, what is it? Not obviously, it's telling you pale green, and it's a solution. In this chapter, it is so important. The colors are so important because the colors give you some basic but very important clues as to what the compound might be. Okay, so this is a gas, colorless gas. All right, so I immediately know that this might be, this might be carbon dioxide. Okay, especially if I know that this is carbonate. Carbonate plus acid gives you carbon dioxide. So immediately I know that actually this is carbon dioxide. I don't need to think about that, right? But remember, you'll be stuck here if you don't know the colors, yeah, and carbonate. So what reacts with carbonates to give you a green precipitate? Iron, carbon, iron. Yeah, so it's an iron complex, Fe2+. Okay, so I'm still thinking, okay, well, what's this green, pale green precipitate? Okay, so what's happened is that this acid is reacted with a carbonate to give you the carbon dioxide. And what's left in this acid? Well, the sulfate, isn't it? And the ion. And so the ion plus sulfate will probably give you, I'm going to go this way, probably give you, so it will be Fe2 plus sulfate will give you iron sulfate. So what's left in the solution after the hydrogens react with the carbonate is the sulfate ion and the ion, Fe2 plus ion. So therefore, these two, yeah, what you find in the actual solution is Fe, iron sulfate. Obviously, these will be dissociated because remember it's ionic bonding, right? So it'll be Fe2 plus ions floating around the solution, sulfate, SO42 minus ions floating around the solution. But the solution will be pale green because of the Fe2 plus. Again, my knowledge comes in, yeah? I know that if this was Fe3 plus, it wouldn't be pale green, it would be brown, it would be light brown. Okay, so it can't be Fe3. Here's another clue that it can't be Fe3, just like that. Okay, so have I identified? Okay, let's start writing things down. So remember, students initially tend to they just write down, oh, bromide. So if they've done it right, they'll say, oh, there's a bromide ion. That's not what this question is asking you. This question is not asking you what's the anion. Yeah, they're asking you what is A. A is a full compound after it's been reacted with silver nitrate. Okay, so this is not bromide. A is actually silver bromide. That's compound A. Yeah, so this is silver. Now I'm writing formula because that's fine. They're saying or formula, name or formula. Yeah, but there's something important you need to remember. Okay, in a minute I'll tell you. Identify B. So there's A. What's B? Well, B is FeCO3. Identify C. C, we just said FeSO4. Identify D. Well, D, I said it's carbon dioxide. Yes. And identify finally Y. Well, if I know that the metal part of this Y is iron. And the non-metal part of this Y is bromide. So this is Fe, okay, FeBr2. Okay. Now, you need to remember something. If you do decide to write names, yeah, identify by name, so not formula but name, you can't just write here, you can't just write iron carbonate. You can't just write iron carbonate, because iron carbonate, you need to tell the examiner, well, which iron is it? Is it iron 2, iron 3? So you've got to write Roman numerals to identify the oxidation state of this iron. So it'll be iron, Roman numeral 2 carbonate. Yeah. If you just write iron carbonate, you won't get the mark. It has to be, if you write the name, it has to be iron 2. If you write the formula, it's understood from the formula. Okay, so just be aware. So that's one of the mistakes that students sometimes make in their rush. They don't identify Roman numerals, they just write down names. Or sometimes they just write down ions, bromide ion, carbonate ion, rather than the actual full compound. Okay, so that's that. All right, well, that's 5 marks. Now, in the exam, if you want to do this, I told you, I tell everyone, yeah, even though some people say, well, there are no such thing as visual or kinesthetic. Well, I'm sorry, but I like to see what I'm doing. Can you see? Yeah, so this is automatically, this is how I would do this question. Obviously, if I'd done this, my memory work, okay, I would probably just from in my head, I would probably identify and realize that this must be silver bromide. Yeah, this must be iron carbonate. I didn't have to do all of this flow chart. Okay, but if you're struggling, it might help. Okay, and if it's taking you more than 5 minutes in the exam, well, go as far as you can with this flow chart, put a star at the top of the page, okay, and then go on to the next question and come back to it later. Okay, but anyway, if you've done the memory work, this question, it'll take you less than 5 minutes. Yeah, if you've done the homework, memorizing, sitting down, memorizing. Weather like this, yeah, day like this when it's raining outside, take some, something that you need to memorize, sit down and just memorize. You can be doing other things while you're trying to memorize things. Okay, next question. So this is part of the same, obviously, question. Write the simplest ionic equation for the reaction of silver nitrate solution with the anion that is present in compound way. Now, simplest ionic equation, yeah, not the full equation, simplest. I'm going to turn this around. In fact, what I'll do is I will simplest ionic equation. Well, the simplest ionic equation for the reaction of silver nitrate. Now, sometimes this is what students do because they realize silver nitrate plus bromide is equal to silver bromide. But this is not a simplest ionic equation, because remember, silver nitrate is an ionic compound, so the simplest ionic equation would be Ag plus Br minus and silver bromide. Now, I'm just looking to see, have they said put the state symbols? They've not said using the state symbols or include the state symbols. Now, in this case, I can leave out the state symbols, although me being a proper chemist and me trying to make sure that I'm impressing the examiner, I would put the state symbols, yeah. But because the question hasn't specifically asked for state symbols, if you're not sure what the state symbols are, leave them out. Okay, so I'm absolutely sure what the state symbols are, so I'm going to put them in. AQ, and a solid. The reason why I say if you're not sure, leave them out, because the question specifically doesn't ask for them. If you put an incorrect state symbol, you will get penalized. Yeah, so if you do decide to put them, even though the question hasn't asked for it, and if you get them wrong, you'll get penalized. However, because the question hasn't asked for it, if you leave them out, you can't get penalized. You won't get penalized. Okay. Okay. So the next question. So there you go. And don't forget, obviously, precipitate. Yeah, solid. Write the simplest ionic equation for the reaction that occurs between the green precipitate B and sulfuric acid. The green precipitate B. Now I know it's iron carbonate. Now, so obviously it will be the carbonate part that's reacting. Simplest ionic equation, it says. So carbonate plus the sulfuric acid. Now you got to think, what part of the sulfuric acid is actually reacting with carbonate? You should know. Whenever acid reacts with a carbonate, it's the H plus. That's the dissociator, isn't it, from the acid? So it's the H plus that reacts with carbonate. So it'll be the H plus, and that gives you carbon dioxide plus water. Okay, now obviously then you got to sort of balance it, don't you? Yeah, so that's 2 H pluses, 2 H's, 1 carbon, yeah, that's fine. Okay, now again, does it say? It doesn't say. It doesn't say, you know, that you need to include state symbols, but again, I would, as I said, impress the examiner. However, if you're not sure, leave them out, okay? But generally speaking, you know, anything that's charged in an equation is usually aqueous, yeah? Because anything that's charged is usually an aqueous, yeah? Just remember that. Carbon dioxide, you know, is a gas, so, you know, it tells you in the question. And of course, water is a liquid, okay? You just put L, okay? Now, what some people do is they react the sulfuric acid, full sulfuric acid, with carbonate. You can't do that because sulfuric acid is ionic. Remember, any acid in solution dissociates, so that exists as ions. So if you do a full sulfuric acid, you know, that would be incorrect. You'll get marked wrong for it. Okay. However, if you decide to do the full iron carbonate, even though it's ionic, but remember, it's a solid, it's a precipitate, so it is together. Okay, it'll only dissociate when it's dissolved in sulfuric acid. Okay, so you can actually do this, and I'm going to do this. You can actually do this where you react the full iron carbonate with H plus. Remember, sulfuric acid is dissociated, so you can't use the full sulfuric acid. Okay, iron carbonate is a solid precipitate, so it is together, so you can use it. Okay, together, okay, rather than just the Fe. And so what you do then is green precipitate and sulfur, and of course then what you do is, yeah, carbonate reacts with H plus, so you get carbon dioxide. Plus water. And the only difference here is you've got to consider the ion. You started with the ion, so you can't just vanish. Yeah, you've got to make sure that you put ion at the end as well. And of course, it'll be Fe2 plus. And then again, it'll be obviously this will be now solid. This will be aqueous. This will be a gas. This will be a liquid, and this will be aqueous because ion. Yeah, because you started with a solid. Okay, solid. And I think. So yeah, so if you do decide to start with a full FeCO3, then remember to include Fe2 plus at the end. I hope you see the reason why I can't start with a full sulfuric acid, but I can start with a full sort of complete FeCO3. I hope you can see that reason. If not, or put in the comment below, ask me, and I'll try and explain it again. Okay, anyway, so that's one mark done. Okay, so this is one of those year 2 questions, and I told you before, examiners love using these sort of letters, just to try and sort of, they've noticed it sort of confuses students, it puts extra pressure on them. Doesn't need to. Follow some kind of a method, and you'll be fine. Do your homework in terms of memorizing things that you need to. Okay, a couple of errors that I am going to go through is name. I've told you, about the names. So if you mention the names, you've got to put the Roman numerals. Sometimes, in terms of here, gas, they suddenly, students suddenly start putting hydrogen gas. Well, hold on, hydrogen gas, a salt, reacting with an acid doesn't give you a hydrogen gas. Yeah, salt can't give you normally a hydrogen gas. It can normally just carbon dioxide. And of course, the other problem is that if you not memorize the colors and the metals, you're going to find this difficult. The other problem here is that they sometimes put FeBr3, in other words, Fe3. Even if they realize that, well, that it's Fe2 plus, however, in a rush, they might put FeBr3, just be careful of that. Remember why it can't be Fe3, because the carbonates with Fe3 plus ions, it'll actually react. Okay, there'll be an acid-base sort of a reaction, and then you'll end up with carbon dioxide here as well, a gas given off here as well. And other problems, students end up writing sort of full equations here, not ionic. Okay, because even though they've said ionic, and you won't get a mark for it if you write full equations. Okay, well, I hope you found that useful. If you've got any comments, put them down, and I'll try and address them as soon as I can. Next week, I'm hoping the video will be a bit different. Okay, so next week's video will be a little bit different. All right. Anyway, give this question a go. Try it yourself. Make sure you understand the reasoning. Print out those summary sheets. Memorize. Remember, there are some things that you can't just have a shortcut for. All right, you just got to do it. Okay. I'll see you next Tuesday. Bye.